sales tax and discounts. So this is probably the most common place that you guys will encounter percentages in real life. So sales tax is a percent of a sale that is paid in addition to the sale price. So that's paying more, and then a discount amount is a percent of a sale I was trying to erase. There we go. That is discounted from the sale price. So they both work very similarly, except with a sales tax, you're adding the amount on. With a discount, you're subtracting. Example 3, suppose the local sales tax rate is 8.2% and you purchase a computer for $1,260. How much are you paying in tax? So you take the price and you multiply it by the sales tax rate, but as a decimal, and that'll give you how much tax you owe. And that gets added on to the sales price. So for a $1,260 computer, you end up paying $1,363.22. So that's over $100 in taxes. Well, we know how much it is exactly. It's $103. So taxes increase the amount that you're paying by quite a bit. A couch costs $850, is on sale this week for 15% off. How much we pay? All right, so we need to do the same thing, multiply by the percent, so 0.15. And that is $127.50. So that's how much you can deduct from the price of the couch. So now it's only $722.50. Of course, you also have to calculate the taxes on that couch, unless for some reason it's tax-free. So it's going to go up again, but that's how discounts work. Caution, sometimes a retailer is taking 50% off already reduced prices. Suppose the sweater is already 10% off, but you'll get an additional 50% off at the register. This does not mean 60% off. You can't just add percentages together like that. We'll see how it works with this example. You're buying a pair of jeans for $100 that are marked down 10%, and then there's an additional 50% off. So let's look at how much, what students who haven't taken this class before might think is that they're going to get 60% off the jeans and only pay $40. However, that's not quite what it comes out to be. So if you find the 10% off, so we multiply by 10% or 0.1, and the reason I picked 100 is because it's easy to work with. So 10% of 100, of course, is $10. And then you subtract the $10, and it's $90 with the 10% off. Then you find, so we'll say this is the 10% off. It's the additional 50% off. We start with the $90, multiply by 0.5, which is $45. And you can subtract $45 from 90. So $45 is how much the jeans cost. And if you incorrectly added the percentages together, then you would find that they're only $40, which would be nice, but not quite correct. So just beware of that you can't add percentages together. You do one, then the other. The order doesn't matter, just that you only do one at a time. Example 5. So this one I'm going to put a little star next to. It's probably the hardest percent problem, and it's also not that common. So you would, well, let me read the problem. Juanita purchased a game console for her grandson. She lost the receipt, but her credit card statement says she paid $453.85. She would like to know how much she paid before taxes. The tax rate in her county is 7.5%. Find the price before tax. So what students do typically is they multiply 7.5% by 453.85 and then subtract that to find what they think is the original price, but that is not quite how it works. So I think it helps to write it out, like just in words. So you have the before tax price, and then you add the tax amount, and that equals the total, which we know is $453.85. And we know that the tax would be 7.5%, so 0.075 times the before tax price. So it's similar to, in example 3, we knew the before tax, so we just multiplied by the tax rate and then added it to get the total. So in this situation, we have this and we have this, but we do not have this, the 1,260. So that's what we're trying to find. So the equation that we're setting up is very similar to what we have here. It's just that we don't know this amount. And we wouldn't exactly know this one because we would have to know the first one to get that. So it's the same situation, just harder because you don't have that before tax amount. So let's call that before tax amount X. And then this one will be 0.075 times X. That's how you find the taxes. So putting that together, it's X plus 0.075X equals $453.85. When you combine these, this is why I mentioned it in that video, this is a 1 here. So 1 plus 0.075 is 1.075X, combining like terms. This is one of the few places where you need to do that in this course. And then finally divide, because it's 1.075x is like 1.075 times x, and to undo multiplication, you divide. And after the division, punching that in the calculator, which I haven't done yet, so I'll do it right now. 85 divided by 1.075. I get 422, and there's a bunch of decimals, but it's money, so we're just going to round to the nearest cent. So, wrapping this up, we say that Juanita originally paid $422.19 for the game console. And you can check, right? You can make sure. So you take the $422.19, you add the 0.075 times that amount. And it should come out to be the $453.85. So I'll multiply that by 0.075. That's 422.19 plus 31.66 equals $453.85. So it works. Now, if you're watching this for the first time and you're thinking, I didn't get that, it's okay. It's difficult. Just watch it a couple more times. And if there's any questions you have about it, make sure you ask them.